Okay, so let's start with the basics. What actually asterisk is asterisk web development? It's really about creating websites and online experiences. The three main technologies you'll need to learn are HTML, CSS, and JavaScript. HTML is how we structure our content. Think of it as the skeleton of a website. CSS handles the look and feel, colors, fonts, layout, like the makeup and clothing for that skeleton. And finally, JavaScript makes things interactive: animations, buttons, anything that responds to user actions. Okay, let's talk about what a front-end developer actually does. Basically, they're the ones who build everything you see and interact with on websites, from buttons and menus to animations and forms. They take design ideas and turn them into something real that users can use. A big part of their job is using HTML to structure content, CSS to style it visually, and JavaScript to make things interactive. They need to make sure everything looks good on any device, like phones and tablets, which is called responsive design. And they're constantly testing and fixing problems to ensure a smooth experience for everyone. Okay, let's start with the basics of HTML. Think of it as the skeleton of a website. It provides the structure and content to make everything work. The root element is the HTML tag, which contains the head and body sections. The head holds information like the title and links, while the body is where all the visible stuff goes. Now, semantic HTML is really important. Instead of just using generic tags, we use tags that tell the browser what kind of content is there, like a heading or a paragraph. This makes it easier for search engines to understand your site and also helps with accessibility for users. Okay, let's talk about some awesome additions to HTML5 that really boosted the power of front-end development. First up are semantic elements like article, aside, nav, header, and footer. They are not just for looks, they help make your websites more accessible to screen readers and improve how search engines understand your content. Next, we have the Canvas API, which is a game changer for creating interactive graphics and animations. Imagine building simple games directly in HTML. Then there's web storage. Local storage and session storage let you store data on the user's computer without needing cookies, making things like offline features or remembering user preferences much easier. And for those location-based apps, the geolocation API lets your website access a user's position with their consent. Finally, HTML5 brought native support for embedding videos and audio. No more clunky plugins. Okay, let's dive into the basics of CSS. It's essentially how you control the look and feel of your website. Think of it as the styling language. It tells your HTML elements how they should appear. We use something called selectors to target specific parts of your page, like headings or paragraphs. Then, we assign properties, which are things like color, font size, and spacing. It's pretty simple once you get the hang of it. The general format is a selector followed by curly braces containing property value pairs. For example, you might want all home tags to be red and large. Now we'll move on to the box model. Okay, let's talk about some awesome CSS3 features that are essential for any front-end developer. First up is Flexbox. It's a fantastic layout system that makes arranging elements super easy and really helpful when you need designs to adapt to different screen sizes. Then we have CSS Grid, which lets you build complex two-dimensional layouts with rows and columns, giving you precise control over your design. And finally, let's not forget CSS animations and transitions. These are a great way to add visual flair and polish to your website without needing extra scripting. Okay, let's talk about responsive web design. Essentially, it's all about making your website look fantastic no matter what device someone's using, whether they're on a huge desktop screen or a tiny phone. We achieve this primarily through flexible grids and media queries. Flexible grids like CSS Grid and Flexbox allow our layouts to adapt automatically as the screen size changes. And then, media queries let us apply specific styles based on things like screen width. Finally, don't forget about that viewport meta tag. It's a small piece of code that tells mobile browsers how to scale your web page. Okay, so let's dive into media queries. They are a really important part of making websites work well across all devices. Essentially, they let us change the look and feel of our site depending on the screen size. Think about how a website looks great on your phone but might need to adjust for your tablet or desktop. Media queries are what make that happen. They're written using the @media rule in CSS, and they allow you to target specific conditions like maximum width, orientation, or even resolution. You can use things like max width to apply different styles when a screen is smaller than 768 pixels. It's all about adapting your design for different devices. Okay, so let's talk about mobile-first design. This isn't just about making your website look good on smartphones, it's a whole mindset. We begin by designing for the smallest screens first. Think really simple layouts and essential content. That forces us to write cleaner, more efficient code, which is great for performance. Plus, mobile users often have slower connections, so optimizing assets early helps everyone load things faster. And importantly, starting small makes accessibility a priority from the get-go. Okay, so let's talk about CSS preprocessors. Sass and Less are like giving your CSS superpowers. They allow you to write styles in a way that's much more organized and reusable than plain CSS. Basically, they take our messy CSS code and turn it into clean, efficient CSS that browsers can actually use. They offer things like variables so you don't have to repeat the same color over and over, nesting, which makes your style rules look really structured, and mixins. Think of them as reusable code snippets for your styles. Okay, let's talk about building responsive user interfaces. We're going to dive into how you can use two incredibly popular CSS frameworks, Bootstrap and Tailwind CSS. Bootstrap is essentially a foundation. It gives you ready-made components like buttons, forms, and navigation bars that are already styled for different screen sizes. Its grid system makes creating layouts super easy. Then there's Tailwind CSS. It's a bit of a different approach. Instead of building things from scratch with pre-built components, Tailwind provides tiny, reusable utility classes directly in your HTML. Think of it like Lego bricks. You combine them to build your design exactly how you want it. Both frameworks help you create consistent designs across all devices and browsers, but Bootstrap is fantastic for getting something up and running quickly, while Tailwind gives you a lot more control over the final look and feel. Okay, so we're starting with JavaScript fundamentals. It's truly the heart of front-end development. Basically, JavaScript is a language that makes websites interactive, allowing them to respond to what users do and change dynamically. We'll cover some core concepts like variable. Think of them as labeled boxes where you can store information, along with different data types like text or numbers. Also, we'll look at how operators work to perform actions on those values, and then how control flow helps us decide what order the code should run in. Okay, let's talk about some super helpful JavaScript additions from ES6 onwards. First up are let and const. Think of let as a variable you can change later, while const is like declaring something that stays the same. Next, we have arrow functions. They are a shorter way to write functions, especially useful when working with callbacks or events. Finally, template literals let you easily combine text and variables within strings, making your code cleaner and easier to read. These are all fantastic tools for any front-end developer. Okay, let's talk about the basic ingredients of JavaScript, our data types and operators. We have primitive types like numbers, strings, booleans, null, and undefined. These are the fundamental building blocks for everything else. Then we've got object types, including arrays and objects themselves, which allow us to store more complex information. And finally, let's not forget about operators. These are symbols that let you perform actions on your data, like adding numbers together or comparing values. There are arithmetic operators for math, comparison operators for checking equality, and logical operators for combining conditions. Think of them as the tools in a developer's toolbox. Okay, let's talk about the DOM. It's super important for front-end development because it's how JavaScript actually talks to your web page. Basically, the DOM is a tree structure that represents all of the HTML elements on a page. It's like a map that lets our code find and change things, add new buttons, update text, or even completely rearrange sections of the page. We use methods like getElement by ID and createElement to do this, making it possible to build dynamic and responsive web experiences. Okay, let's talk about how websites actually react to what you do. In JavaScript, we use something called event handling. Basically, it's all about making sure that when a user clicks a button, or types in a form field, or even just hovers their mouse over something on the page, our code knows to respond. There are key concepts like events themselves. Those are things happening in the browser, like a click or a key press. Then we have event listeners, which are functions that wait for specific events and then do something when they happen. And finally, there are event objects, which give us information about the event itself, such as what element triggered it. Let's look at a simple example attaching a click handler to a button. This means when you click that button, a small message will appear in your browser's console. It's a fundamental building block for creating dynamic and engaging web experiences. Okay, let's talk about functions and where variables like that scope. Functions are really useful little programs we can reuse. They take in some information, do something with it, and give us back a result. Think of them as mini programs inside our bigger program. JavaScript has 3 different levels of scope to understand. Global scope means any function can access variables declared outside any specific function. Function scope is when variables are only accessible within the function itself. And finally, we have block scope with let and const, meaning they are only available when they were defined like inside an if statement or loop. Okay, let's talk about closures and hosting. They are fundamental to how JavaScript works. A closure is essentially a function remembering the variables around it, even after the outer function has finished running. Imagine it like a little memory space just for that inner function. It's really useful when you want to maintain state between different calls. Then we have hoisting. Basically, JavaScript moves variable and function declarations to the top of their scope before executing your code. But here's the catch, only the declaration itself gets hoisted, not the value assigned to it. So if you try to use a variable before declaring it, you'll get undefined. Function declarations however, are fully hoisted and ready to go. Okay, let's talk about asynchronous JavaScript. Traditional code runs line by line, but many things we do online like loading data from a server take time, right? That's where asynchronicity comes in. We first learned about callbacks, which are functions you pass to other functions that get executed later. Promises were created to offer a more structured approach to handling these asynchronous results. They represent the eventual outcome of an operation, and they have states like pending, resolved, or rejected. Finally, async/await builds on promises, making asynchronous code look almost like regular synchronous code, which is much easier to read and understand. Okay, let's talk about JavaScript error handling. It's a really important part of being a good front-end developer. Essentially, we want our websites to be as stable and predictable as possible. When things go wrong in our code, we need a way to catch those errors and handle them gracefully, so the website doesn't just break. The core tool here is the try-catch block. This allows us to wrap sections of code that might potentially cause an error, like dividing by 0, for instance, within a try block. If an error does occur inside the try block, the code jumps to the catch block where we can handle it, log it, or even display an informative message to the user. We also have error objects, which are different types of errors that tell us more about what went wrong. Throwing errors is a way to deliberately signal issues in our code. And finally, try-finally blocks guarantee that certain cleanup actions will always happen, such as closing connections or releasing resources, whether an error occurred or not. Okay, let's talk about how we connect our front ends to the back end. We'll focus on JSON and AJAX. First up is JSON. It's like a really easy to read way for servers to send data back to us in a structured format using key-value pairs. Think of it like a dictionary. Next, let's look at AJAX, which stands for Asynchronous JavaScript and XML, though now it almost always uses JSON. AJAX lets our web pages update information without needing a full page reload, making things much faster and smoother for the user. Okay, let's talk about how front-end developers bring their apps to life by connecting them to the back end. We're specifically looking at REST-file API, essentially a standardized way for frontends and backends to communicate. Think of REST-file API as a set of rules for requesting and receiving information. It uses common things like HTTP methods get, post, put, delete to tell the server exactly what you want to do. The data is often exchanged in JSON format, which makes it easy to work with on the front end. It's all about making those requests using JavaScript and then processing the responses. Let's look at a simple example of how a JavaScript fetch call would make a request for user information. Let's talk about how your browser and servers communicate. HTTP methods are basically instructions like get, which asks for something, post, which sends information to create or change things, put to replace a whole thing, patch to update just part of it, and delete to remove it. Then there's a whole range of status codes that tell you what happened with your request. A 200 means everything went smoothly, like, here's the data you wanted. A 201 says, yay, I made something new. 404. That usually means the page you were looking for doesn't exist. Understanding these methods and codes is key to debugging front-end applications. Okay, let's talk about CORS cross-origin resource sharing. Basically, it's a security feature that lets your website safely grab data from other websites. Without CORS, browsers block JavaScript running on one site from accessing resources on another because of something called the same origin policy. This policy is there to protect users' data and prevent malicious scripts. The server tells the browser whether or not it's okay to access a specific resource by sending back an access control allow origin header in its response. If your site's origin is listed in that header, you're good to go. If it isn't, or if it says asterisk, you need to be extra careful. Okay, so when it comes to building modern web apps, front-end frameworks are absolutely essential. Think of them as toolboxes packed with pre-built components and powerful features that speed up development. We'll look at a few popular ones: React, Angular, and Vue.js. React is super flexible because it uses something called a virtual DOM, which makes updates really efficient. Angular is a more complete framework, often used for bigger projects, and it utilizes TypeScript. And then there's Vue.js. It's known for being relatively easy to pick up, so you can quickly integrate it into your existing code. Okay, let's talk about React. It's basically a tool that helps us build interactive websites and apps. Think of it like Legos for building UI. You have these reusable components that you can combine to create complex interfaces. A core idea is that everything in React is built around components. And we use something called JSX, which lets us write HTML-like code within our JavaScript, making things easier to read and write. Finally, React uses a clever trick called the virtual DOM, which speeds up updates by only changing what's necessary. Okay, so let's talk about component-based architecture. It's a really important idea in front-end development. Basically, instead of building huge, monolithic interfaces, we break them down into smaller, reusable pieces called components. These are like Lego bricks for your website or app. You can use the same brick multiple times and they all work together seamlessly. It makes things much easier to maintain, test, and scale as your project grows. Plus, it's a huge time saver because you don't have to reinvent the wheel every time. Okay, let's dive into the core hooks that are essential for building dynamic React applications. First up is useState. It's like a simple state variable. You initialize it with an initial value and then have a function to update it whenever your component needs to change something. Next, we have useEffect, which lets you handle side effects in functional components, such as fetching data or setting up subscriptions. Finally, there's useContext. This hook is fantastic for sharing data across your entire component tree without having to pass props down through every single level, perfect for things like themes or user authentication. Ready to move on? Okay, so let's talk about how we keep track of data in our React apps. Managing state, that's the data that drives your UI, can get complicated quickly. We've got a few different tools to help us do it well. First up is Redux, which is really powerful and good for bigger projects where managing complex data flows becomes important. Then there's React's built-in context API This lets you share information between components without having to pass it down through every single level of your component tree, perfect for smaller pieces of state. And finally, we have Zustend, which is a really cool, lightweight global state management library that's becoming increasingly popular because it's super fast and easy to use. Okay, so let's talk about routing in React. Think of it like creating a website that doesn't reload every time you click a link. React Router is the tool we use to make this happen. It's built around components and routes. Each route corresponds to a specific URL path and tells React which component to display when someone visits that page. We can easily create navigation links using the link component, and it all starts with wrapping your main app component in a browser router. Okay, let's dive into Vue.js. It's a super popular framework for building user interfaces, and it's really known for being easy to pick up. At its core, Vue lets you build reusable components like little building blocks that you can use throughout your application. You'll be working with templates, which are essentially HTML structures that tell Vue what to display. A key thing is data binding. This means if your data changes, the Vue automatically updates. And reactivity? That's just a fancy word for Vue efficiently keeping things synchronized. Let's move on to learning more about components and how they work. Okay, let's talk about building user interfaces with Vue.js. Today we're focusing on two really important concepts: directives and components. Think of directives as special instructions you give to Vue, like telling it to connect a form field directly to its value, or showing or hiding content based on certain conditions. We've got things like vModel for easy data binding, vif and velse for conditional rendering, and vfor to loop through lists of items. Now components are where the real power lies. They're essentially reusable building blocks for your UI, little self-contained applications within your larger Vue app. They help keep everything organized, make it easy to reuse parts of your interface in different places, and they encapsulate their own styles and logic, which makes things much cleaner. Okay, let's talk about Vue Router and Vuex. These two are a really powerful combination for building modern Vue applications. Think of Vue Router as your app's map. It controls how users move between different sections or views without needing to reload the entire page. It does this by defining routes and using navigation guards to manage access. Then we have Vuex, which is like the central brain managing all the data in your application. It keeps everything consistent, making it much easier to maintain larger projects. Vue Router relies on Vuex to track where users are navigating, so they are intrinsically linked. Okay, so let's dive into Angular basics. It's a really popular framework for building modern web apps. Essentially, you build your app using components. These are like self-contained chunks of UI that handle their own data and logic. You use templates to define how those components look, and data binding helps keep everything synchronized seamlessly. And don't forget modules. They help organize your entire project so it's easy to manage as it grows. Okay, let's dive into TypeScript. It's a fantastic tool for front-end developers because it adds type safety to JavaScript. Think of it like this: you get the flexibility of JavaScript with the reliability of checking your code before runtime. We'll cover why it's useful, some key concepts like types and interfaces, how classes and objects fit in, and even touch on generics. And here's a simple example to illustrate how TypeScript helps you define what data your functions expect. It really makes your code cleaner and easier to maintain as your projects grow, and that's a big win. Okay, let's talk about how we ensure our code is working correctly, specifically when building frontends. We're focusing on type checking and interfaces. Type checking is like having a super smart grammar checker for your JavaScript or TypeScript code. It makes sure that the data you're using is of the correct type, whether it's a number, a string, or something else. It finds these errors before they cause problems in your application. Now TypeScript builds on top of JavaScript and adds static typing, which means we can define what types our variables and objects should be. Interfaces are basically blueprints for how an object should look like, defining the shape it needs to have. Think of it as saying this object must have these properties. TypeScript and interfaces help us catch errors early on, make our code easier to understand, and give our tools like IDE a better way to assist us. Okay, let's talk about how to keep your TypeScript code organized. We're going to look at modules and namespaces. They are like building blocks for larger applications. Modules bundle related pieces of code together, making it easier to reuse them in different parts of your project. You use import statements to bring in only what you need. Then, namespaces are a way to group things under a single name to avoid any confusing naming clashes, especially when you're using external libraries. They help keep everything neat and tidy, really important as projects grow. Okay, let's talk about single-page applications. Basically, SPA are a different way of building websites compared to the traditional approach where you click a link and an entirely new page loads. With an SPA, everything happens on *1* page. It's like a mini application running in your browser. They use JavaScript frameworks like React, Angular, or Vue.js, along with routing libraries and state management tools, which helps keep track of all the data within the app. This results in a much smoother, faster user experience because you don't have to wait for entire pages to reload every time you click something. Let's talk about progressive web apps. Think of them as websites that feel *like apps. They're built using modern web technologies and offer some seriously cool features like working offline, being installable on your home screen, and sending you notifications just like a regular app. They are also much faster to build than traditional native apps, making them a really attractive option for developers. Let's talk about service workers. Think of them as unsung heroes behind the scenes in your web apps. They are essentially JavaScript files that run independently of your browser, allowing your app to be available even when there's no internet connection. Pretty cool, right? They can store and deliver content, handle background updates, and even send push notifications with user permission, of course. Essentially, they're the key to a seamless experience for your users. Okay, let's talk about making your websites lightning fast. Web performance optimization isn't just a nice to have. It's crucial for user experience and even how Google sees you. First off, think about why speed matters. Happier users, better search rankings, and people are more likely to stick around if things load quickly. There are several key strategies we can use. We want to reduce the number of times a browser has to ask for files. That means combining CSS and JavaScript into fewer requests. Images need to be optimized to compressing them and making sure they're sized correctly for different devices. Caching is also really important, helping browsers store things locally so they don't have to fetch them again. And finally, let's make sure our code itself is minifying HTML, CSS, and JavaScript, removes unnecessary characters and reduces file sizes. Don't forget about deferring the loading of non-essential scripts and stylish sheets, so those things don't block your page from rendering. Okay, let's talk about making your websites load super fast. We're going to cover lazy loading and code splitting, two powerful techniques for optimizing front-end performance. Lazy loading essentially means you only load images or scripts when they're actually visible on the screen. It's like a surprise reveal instead of everything showing up at once. And code splitting? That's where we break your large JavaScript bundle into smaller pieces so the browser only downloads what it needs for each part of the page. Think of it as downloading chapters of a book instead of the whole thing upfront, much better for those impatient users. Okay, let's talk about tree shaking. It's a super cool optimization for front-end developers. Basically, it's like a really smart way to reduce the size of your JavaScript files. Think about all those libraries you use. Sometimes you only need a small part of them. Tree shaking figures out which code is actually used in your application and automatically removes anything that isn't. It works by splitting up large bundles into smaller chunks, analyzing what's being used in each chunk, and then tossing the unused bits away. Some popular bundlers like Webpack, Rollup, and Parcel all support this feature. Okay, so Webpack is like a super organizer for your front-end projects. Think of it as a master assembly. It takes all the different pieces of code and assets you have scattered around, like JavaScript files, CSS styler sheets, images, and more, and bundles them into smaller, optimized packages that your browser can easily understand and load. It's especially helpful when you're working with complex projects with lots of dependencies. Webpack helps manage these dependencies and ensures everything works together smoothly. It also allows for code splitting, which means it only loads the parts of your application that are currently needed at any given time, leading to faster initial loading times. There are key concepts like an entry point where Webpack starts building from an output directory where it puts all the bundled files, and loaders which allow it to process things like SAS or images. And finally, plugins which let you customize how Webpack works. Let's move on to looking at some common examples of these loaders. Okay, let's talk about two really helpful tools for building modern websites, Parcel and Vite. Think of them as helpers that make bundling your projects super easy. Vite is like the speedy build. It uses something called native ES modules, which means changes you make in your code appear instantly in the browser without a full rebuild. That's fantastic for development speed. It also has hot module replacement, so updates happen almost instantly. Parcel, on the other hand, is an all-in-one solution that doesn't require much configuration at all. It automatically splits up your code into smaller pieces and optimizes it for production builds. For new projects, Vite often wins out due to its speed, but Parcel is still a great choice if you need something really straightforward. Okay, so let's talk about a really important part of front-end development, browser compatibility. You see, every browser, Chrome, Firefox, Safari, Edge, interprets code slightly differently. This means websites often don't look or work exactly the same way on every single device you might encounter. We'll cover some common problems like layout shifts and CSS feature differences. Fortunately, there are ways to tackle these. Things like polyfills, CSS resets, and using feature detection can help ensure your website is as consistent as possible across the board. And remember, thorough testing is absolutely key. Okay, let's talk about how we make sure our cool new JavaScript code works for *everyone*. Essentially, modern JavaScript is awesome, but older browsers might not get it. That's where transpilers and polyfills come in. Transpilers like Babel are like translators. They take your newest JavaScript, think ES6 or later, and convert it into something older, like ES5, so that older browsers can understand it. Then polyfills are like little helpers that add features to browsers that don't have them built in. So if you're using a feature that wasn't around when the browser was created, a polyfill makes sure it works just fine. Babel is often your go-to transpiler, and with a good configuration, it can handle most of the translation work for you. Okay, so let's talk about Git. It's a lifesaver for front-end developers. Basically, Git is a system that keeps track of changes to your code. Imagine you're working on a big project and you want to try out something new, but you don't want to mess up the main version. That's where branches come in. They let you create separate lines of development. You commit your changes, essentially taking snapshots, and then you can merge them back together when you're happy with the result. Don't worry if that sounds a bit confusing. Just start using the basic commands like clone, add, commit and push, and you'll quickly get the hang of it. Okay, so let's talk about branching. When you're building a website or web app as a front-end developer, keeping your code organized is super important. Two really popular ways to do this are Git Flow and GitHub Flow. Git Flow is like having a very specific roadmap. You have a main branch for the live site, a develop branch where new features get combined, and then separate branches for things like releasing updates or fixing urgent bugs. It can be a bit complex to manage though. GitHub Flow is much simpler. Basically, you start on the main branch, create a new branch every time you want to work on something, make your changes, and merge them back in. This works really well if you're using automated testing and deployment. It's all about keeping things moving quickly. Okay, so when you're building a front-end project, you'll inevitably end up using lots of external libraries, things like React or Vue, or even just some simple helper functions. Managing all those dependencies can get tricky. That's where package managers come in. We have three main ones: npm, which is pretty much the standard that comes with Node.js, Yarn, which was built to speed things up and make sure everyone's using the same versions of libraries, and PNPM, a newer option that's gaining popularity because it's really simple and fast. Let's take a quick look at how they compare. NPM is still super popular, Yarn is known for being fast, and PNPM is all about making things easy. Let's talk about making websites accessible for everyone, including people who use assistive technologies. ARIA stands for Accessible Rich Internet Applications, and it's a set of tools we can use to provide more information to those technologies. Think of it as giving screen readers extra context about what things are on the page. WCAG, the Web Content Accessibility Guidelines, sets out some key requirements, like making sure things are visible, operable with keyboards, and understandable. ARIA attributes like ARIA label, ARIA labeled B, and ARIA described B help us meet those needs by telling screen readers exactly what an element does. We'll use these to give clear labels where needed, define the purpose of buttons and menus for keyboard users, and link elements with more detailed information. It's really important to test your designs with a screen reader to see how they work. Okay, so let's get practical. As a front-end developer, you have a huge impact on how easily search engines can understand and index your website. Start by using proper semantic HTML. Think about the structure of your content and use tags like article, section, and nav to give it meaning. Then, pay attention to meta descriptions and title tags. They are essentially summaries for Google. Make sure they are accurate and engaging. Don't forget URL structure. Keep them clean and include relevant keywords. And finally, optimizing images, compressing them to be smaller helps a ton with page load speed, which is a big ranking factor. Okay, so let's get our images working really well across all devices. A big problem is that huge image files can make websites slow to load, especially on phones. To fix this, we use something called src set and the NLT picture and GT element. Basically, src set lets us give the browser multiple versions of an image, one small, one medium, one large, and it figures out which one is best for the user's screen size. The NLT picture and GT tag gives you even more control, letting you show completely different images based on things like if it's a dark mode website. It's all about serving up the right image at the right size so your site loads quickly and looks great no matter where people are viewing it. Okay, so today we're starting our journey into the world of drawing on the web. We'll be looking at two main tools, Canvas and SVG. Canvas is basically a blank area where you can draw anything you want using JavaScript. It's super powerful for animations and interactive graphics because it directly controls the pixels. SVG, on the other hand, uses a special XML format to describe your images. It's like creating a blueprint. It scales perfectly without getting blurry. Both offer different strengths. Canvas is often faster for complex things, while SVG excels in scalability and accessibility. Okay, let's talk about WebSockets. Basically, they are a way to create truly real-time communication between your web app and the server. Think of it as an always open connection, unlike regular website requests which need to be repeated constantly. WebSockets keep that channel open for continuous data exchange. It starts with a simple HTTP handshake, but after that, you get a persistent link where information can flow back and forth instantly. This is super useful for things like chat apps or live games where you want immediate updates without any delays. We'll explore some common applications later on. Okay, let's talk about WebAssembly. It's basically a new way to write code for the web that's incredibly fast. Imagine it like assembly language really close to the computer hardware. Developers can use languages like C++ or Rust to write code and compile it down into WebAssembly, which browsers can then run directly. This means things like games, video editing tools, and simulations can run much smoother on the web than they used to. It's not trying to replace JavaScript, though. Instead, it works alongside it, letting you leverage existing codebases while boosting performance where needed. Okay, let's talk about keeping our website safe from the front end. As front-end developers, we need to be aware of common attacks like XSS, where bad code gets injected into your site through user input. The best defense is a multi-layered approach. First, always validate and sanitize any data coming from the user. Think of it like checking if someone's trying to sneak in something dangerous. Next, you absolutely must encode or escape your output before displaying anything to the user. This stops malicious code from running in their browser. Then there's Content Security Policy, a powerful tool that lets you tell the browser exactly which sources it's allowed to load, dramatically reducing the risk of XSS. Finally, HTTP Strict Transport Security ensures everyone connects through HTTPS, protecting against man-in-the-middle attacks. Front-end security is a continuous effort. Stay informed and keep your code secure. Okay, let's talk about input validation. It's a really important part of building good web apps. Basically, it means checking that the information users type in is what you expect it to be. Why do we need this? Well, it helps us protect our apps from security threats, make sure our data stays accurate, and gives users helpful messages if they make mistakes. There are two types: client-side validation, which happens in the user's browser using JavaScript, and server-side validation, which is done on the server end. That's the one you really want to focus on for security. Okay, let's talk about keeping your web applications safe. Specifically, we're tackling XSS and CSRF, two common vulnerabilities that front-end developers need to be aware of. XSS is when an attacker injects malicious scripts into a website, potentially taking over user accounts or stealing data. It comes in different forms, like stored XSS where the script lives in your database, or reflected XSS where it's directly tied to user input. Now, CSRF, that stands for cross-site request forgery, is a sneaky attack where an attacker tricks you into performing actions on a site without realizing it. Think of it as someone forging a request on your behalf while you're logged in. To combat these issues, we use things like careful input validation to clean up all the data coming from users, and output encoding to ensure that when the information is displayed, it isn't interpreted as code. And finally, using same-site cookies can provide an extra layer of protection against CSRF attacks. Security is a continuous effort, so keep learning and staying updated on the latest threats. Okay, let's talk about Content Security Policy, or CSP. It's a really important security tool for any front-end developer. Essentially, it's a way to tell your browser exactly where it's allowed to load resources like scripts and style sheets from. Think of it as a digital bouncer controlling who gets into your website. We define this policy using a meta tag in our HTML telling the browser what sources are trusted. You can then set directives like script src or style src to specify allowed domains. CSP significantly reduces the risk of cross-site scripting attacks, which can be really harmful to users and your website's reputation. It's all about giving you greater control and boosting that security. Okay, so let's dive into cookie security. Cookies are super useful for remembering user information, but they can also be a target for attacks like XSS and CSRF. That's where the same site attribute comes in. Think of it as a gatekeeper that controls when a cookie is sent along with requests from different websites. There are three settings: strict, which only allows cookies to be sent from your own site; lax, which lets them through for top-level navigation like clicking links, and none of which we really shouldn't use because it opens up significant security risks. The best practice is always to set the same site attribute when creating cookies, prioritizing strict or lax depending on your application's needs. Okay, let's talk about securing your front-end apps. When you need to protect certain areas of your website or app like a user's profile or a payment system, you can't just ask the user for their password and store it directly. That's a huge security risk. Instead, we use tokens. Specifically, JSON Web Tokens, or JWTs. Think of them as digital ID that prove who the user is without actually sharing their secret credentials. They are stateless, meaning the server doesn't need to remember anything about previous logins. And OAuth 2.0 is a clever framework that helps us with this process. It lets users grant access to their accounts on other services to our application securely. Okay, let's talk about unit testing. As front-end developers, it's crucial we write tests for our components and functions. Essentially, making sure they do what they're supposed to. There are a few popular frameworks out there that make this process much easier. We have Jest, which is super popular especially with React projects because of its ease of use and zero configuration. Mocha is a really flexible framework that lets you customize almost everything. And then there's Jasmine. It takes a slightly different approach, focusing on behavior-driven development. Each has strengths, so exploring them is a great way to find the best fit for your project. Okay, let's talk about testing components, a really important part of building good front-end apps. We'll cover two popular tools, React Testing Library and Vue Test Utils. React Testing Library is all about how the user interacts with your application. It focuses on what they see and do, not necessarily the internal code structure. Think of it like testing from the user's perspective. Vue Test Utils is a similar tool for Vue components, offering functionalities to access component context and perform assertions. Both are designed to help you build reliable and maintainable front ends. Okay, let's talk about end-to-end testing. This is all about making sure that when a user interacts with your website or application, clicking buttons, filling forms, navigating pages, everything works together perfectly. We have a few popular tools to help us do this. Cypress is known for being super fast and easy to use for developers. Playwright offers excellent cross-browser support, and Selenium is the long-standing industry standard that's very flexible, though it can be a little more complex initially. Okay, let's talk about CI/CD. It's a really important part of modern front-end development. Basically, it's all about making sure we can quickly and reliably get new features and updates to our users. Think of continuous integration as constantly checking that everyone's code is working together smoothly, with automated tests running after each change. Then continuous delivery takes that a step further by automating the release process, getting those tested changes ready for deployment. And finally, continuous deployment goes even further, automatically deploying new versions to our live website or our app. It's like an assembly line for software. Okay, let's talk about getting your front-end code out into the world, deploying it. It's not just about pushing to GitHub. There are several strategies you can use, and each has its pros and cons. For simple single-page apps or static websites, services like Netlify and Vercel are fantastic because they're super fast and have built-in continuous integration and deployment. If you need dynamic content or API endpoints, serverless functions, things like AWS Lambda or Azure Functions can be a really good option, as they let you run code without managing servers yourself. And finally, if you want more control over your environment, traditional hosting providers like Heroku or DigitalOcean are still viable choices. Okay, so deploying your website is a crucial step. It's what makes it accessible to everyone. We've got three main routes we can take. First up, GitHub pages. This is super simple if you just have a static site like a portfolio or documentation. It's completely free and built into GitHub. Next, Netlify is fantastic for projects with more moving parts, think dynamic content or even adding small server-side functions. Finally, Vercel really shines when you're using the Next.js framework, but it works great with other frameworks too. It's designed to deliver your site super quickly from edge servers all around the world. Let's pick the one that fits your project. Okay, let's talk about speeding up your front-end apps. One really effective technique is using a cloud CDN. Basically, it's like having copies of your website's files, images, fonts, JavaScript stored in servers all over the world. When someone visits your site, they get those files from the closest server to them, which dramatically reduces loading times. It's a fantastic way to boost performance and provide a smoother experience for users worldwide. Think of it as having little local copies of everything. Okay, let's talk about micro frontends. Basically, instead of one huge, complex front-end application, we break it down into smaller, independent pieces. Think of each piece as a miniature app and they're built and managed by separate teams. This allows for faster development cycles, lets us use different technologies for different parts of the site, and makes scaling our applications much easier. It's like building with Legos. You have individual bricks that work together to create something bigger. Okay, let's talk about how we organize our front-end code. Traditionally, Most projects use a polyrepo approach. That means each feature, library, or even whole app has its own separate repository. It's simple to understand initially, and it can work well for smaller teams working on distinct things. But as things grow, you start seeing problems. Lots of duplicated code, complicated ways to manage dependencies between those repositories, and it becomes harder to share components across projects. Now, there's another strategy called monorepo. Instead of having everything in one place, everything lives in a single repository. This can sound daunting at first, but it actually offers some major advantages: less code duplication, easier component sharing, simpler dependency management, and generally smoother collaboration. There are definitely trade-offs involved, like potentially larger repositories and longer build times if you're not careful, but for many teams, the benefits outweigh the challenges. Okay, let's dive into Storybook. It's essentially a really cool tool that helps us build and test our individual UI components in complete isolation. Imagine you have a button with Storybook. You can focus just asterisk on that button without worrying about the rest of your application messing it up. It's fantastic for ensuring things work as expected, making them super reusable across different projects, and even generates beautiful documentation to help explain how they should be used. It really streamlines collaboration too. Okay, let's talk about Figma. It's absolutely essential for any front-end developer. Think of it as the central hub for all things design. It's not just for designers. You can actually use it to create prototypes and even build out components that your developers can then implement in code. Figma makes collaboration super easy. Everyone's on the same page, seeing the latest changes in real time. And importantly, it has robust version control, so if a design needs tweaking, you can easily go back to an earlier version without any headaches. Okay, let's talk about how Agile fits into front-end development. Think of Agile as a way to build software in short bursts, usually 1-4-week cycles we call sprints. Each sprint focuses on delivering a set of features. During these sprints, teams have daily stand-up meetings where everyone shares what they're working on and any roadblocks they've hit. We also use user stories, basically describing features from the user's point of view to ensure we're building things that people actually want. Finally, Agile encourages automation CI/CD so changes can be tested and deployed quickly, giving us faster feedback. Okay, let's talk about how Agile ceremonies keep things moving smoothly in front-end development. We start with sprint planning, where the team decides exactly what features will make it into the next sprint, really focusing on prioritizing what's most important. Then comes the daily stand-up, a quick 15-minute check-in where everyone shares their progress, any roadblocks they're facing, and what they plan to tackle today. It's all about transparency and getting those issues sorted out quickly. Next up is the sprint review, where we show off the work we've completed to our stakeholders, get their feedback, and make sure we're on the right track. Finally, we have the sprint retrospective. This isn't a blame game, it's about honestly discussing what went well, what didn't, and how we can improve as a team in the next sprint. These ceremonies are absolutely key to keeping front-end development productive and delivering amazing products. Okay, let's talk about code reviews. They are super important for any front-end project really. The goal is to make sure the code we're adding is clear, easy to understand, and works correctly. We want small pull requests so they're easier to review, and definitely test everything with tests. Looking for edge cases and bugs is also key. Don't just spot mistakes, offer suggestions for improvement by explaining why things could be better. And remember, consistency matters. Stick to project style guides. Do you have any questions about this? Okay, let's talk about documentation. It's seriously important when you're building front-end projects. First, pick a style guide to keep things consistent across your whole team. Markdown is a really popular choice because it's readable and easy to work with. Then think about the different types of docs you need, detailed information about each component, how to use external API, style guides for visual consistency, and guidelines for contributing to the project itself. Remember to keep things clear and concise, always include examples, and most importantly keep your documentation up to date. Tools like Storybook and Docusaurus can really help with this. Okay, let's talk about API First Design, a really important concept for front-end developers. Basically, it means designing your backend API * before * you build the user interface. Instead of building the UI and then figuring out how to get data, you start with the API that define what needs to be delivered. This approach offers tons of benefits. It gives you flexibility. If things change on the backend, you don't have to rebuild the whole front end. It also allows you to reuse your API across different platforms like web apps and mobile apps. And it makes testing much easier because you can test the API in isolation before connecting it to any UI. Okay, let's dive into GraphQL. It's a really powerful tool for front-end developers. Basically, with REST, you often get more data than you actually need from an endpoint, like getting customer details * and * their entire order history when you only wanted the customer's name. GraphQL changes that by letting your frontend specifically request * only * the information it needs. It's all about flexibility and efficiency. Okay, so let's talk about how static site generators are changing the game in front-end development. These tools like Next.js, and Gatsby basically take your code and build out fully rendered websites ahead of time. This means super fast loading times because there's no need for a server to process every request on the fly. They're also fantastic for SEO because search engines can easily understand the content when it's already built. And, honestly, they make building websites much more efficient and enjoyable for developers. Okay, let's talk about Jamstack. It's a really popular approach to building websites today. Instead of relying on a traditional server-side setup, Jamstack breaks things down into 3 key parts: the front-end, which is built with HTML, CSS and JavaScript like React or Vue, an API layer that handles all the data requests, and a serverless backend to actually store that information. The beauty of Jamstack is how quickly it loads, how secure it is, and how easy it is to scale as your website grows. It's really gaining traction for its developer experience too. Let's talk about component libraries. They are a huge time saver for front-end developers. Essentially, they give you pre-built UI elements like buttons and forms, so you don't have to build them from scratch every single time. We'll cover some of the big players, like Material UI and Ant Design. Both are fantastic options that can dramatically speed up your development process and help you create a consistent look across your application while also ensuring good accessibility. Okay, let's talk about implementing dark mode in your front-end projects. Dark mode isn't just a trend, it really can make some websites more comfortable to use, especially at night. We'll be focusing on a simple and effective approach using CSS variables. First, we define some core color variables like background colors, text colors, and primary colors. These will act as the foundation for both light and dark modes. Then, we create specific styles for our dark mode theme, overwriting those variables to shift everything towards a darker palette. Finally, we use JavaScript to add or remove a dark mode class from the body element, triggering the switch between the two themes. Okay, let's talk about making your web apps accessible to a global audience. That's where localization and internationalization, or EHN, comes in. Basically, internationalization is the process of designing your application * to be * adaptable for different languages and regions. EHN is how you actually * to the adaptation. It's about making sure your app speaks to users effectively wherever they are. We start by figuring out what language a user prefers, that's locale detection. Then we store all the translated text in separate files for each locale. Finally, our application dynamically loads the right file based on what the user has selected. Okay, let's talk about making our web apps feel truly interactive. We're going to explore real-time features, those elements that update automatically without needing a full page refresh. The core of this is using something called sockets. Imagine it like setting up a direct phone line between your website and the server. Sockets create these persistent connections, allowing for constant data flow. Now, push notifications are another fantastic way to deliver instant updates directly to users' browsers. Think of new messages popping up in a chat window without you having to manually reload the page. Essentially, Sockets provide the backbone for this continuous communication, then push notifications are where the server actively sends information to keep everything fresh. Okay, let's talk about making data really pop. We'll be looking at two popular libraries for creating charts and visualizations in front-end development, Chart.js and D3.js. Chart.js is fantastic if you want something quick and easy to get started with. It has a simple API and supports lots of different chart types like bar graphs, pie charts, and even scatter plots. It's great for building interactive dashboards quickly. Now, D3.js is a whole other beast. It's more powerful, but also more complex, giving you complete control over how your data is displayed on the screen. You'll be manipulating the DOM directly, which allows for really custom and dynamic visualizations. Think elaborate animations or incredibly detailed charts. Ultimately, the best choice depends on what you're trying to achieve. Do you need something ready to go, or are you willing to invest the time to build something truly unique? Okay, let's talk about drag and drop. This is a really cool feature that makes websites way more interactive. Basically, it lets users move things around on the page like reordering list items or dragging files into a new folder. We'll cover some of the core concepts first. What's the drag source? What's the drop target? And how do we use event handlers to make it all work? It's a fundamental skill for any front-end developer to have in their toolbox. Okay, let's talk about a really clever tool in the front-end developer's toolbox, the Intersection Observer API. Basically, it helps your website react to when elements come into view as you scroll. Imagine a hero image that fades in only after you've scrolled down a bit. That's where this comes in handy. The API lets you set up an observer that watches for intersections with other scrolling elements like the whole browser window. You tell it which elements to watch and what should happen when they become visible, maybe show a button, trigger a loading animation, or even load more content. It's incredibly efficient, avoiding constant scroll checks and making your web pages feel smoother and more responsive. Okay, let's talk about custom web components. These are a really powerful way to build reusable UI elements for your front-end projects. Think of them as like creating your own HTML tags that you can use over and over again. The key thing is encapsulation. The styles and scripts inside a component stay isolated, so they don't interfere with other parts of your website. We'll cover things like shadow DOM, which keeps components self-contained, custom elements to define new tags, and templates and slots for flexible content. It's all about building modularity and making your code much easier to manage. Let's talk about how we can save data directly in a user's browser. We have three main options: local storage, session storage, and IndexedDB. Local storage is like a persistent diary. It holds data for as long as the user has that tab open. You store things as key value pairs, like usernames or preferences. Then there's session storage, which is more like a temporary notepad. It only remembers information while the browser tab is actively being used and disappears when you close the tab. Finally, we have IndexedDB. It's a full-fledged database within the browser, really powerful for managing larger amounts of data in complex scenarios. Okay, let's talk about progressive enhancement. It's a really smart way to build websites. The basic idea is to start with the absolute essentials: solid HTML structure and reliable CSS styling that works on every browser, including older ones or those without JavaScript support. Think of it as building a robust foundation. Then, we add more advanced features like animations, interactive elements, and dynamic content using JavaScript, but only when browsers can actually handle them. So, if someone's browser doesn't have JavaScript, they still get the core functionality, and users with modern browsers get an even richer experience. Okay, let's dive into building apps that don't completely break down when you lose your internet connection. We're focusing on offline-first applications. These are designed to deliver a great experience even if the network is shaky or gone entirely. The core idea revolves around storing data locally using things like IndexedDB or local storage, so users can still access and interact with their app content. Then, we need to carefully manage how that local data changes and synchronizes with the server when connectivity does return. Think of it as the app having its own mini database, working independently and then smartly updating itself periodically. Okay, let's talk about how to keep your users happy while things are loading. We're going to focus on two really important techniques: skeleton screens and loaders. A skeleton screen is basically a blank outline of what's coming up on the page. It gives the user a sense of where everything should be, so they don't think something went wrong when they are waiting for content. It's like showing them a blueprint before the building is finished. And then we have loaders, which are animated spinners or circles that let the user know you're actively working behind the scenes, processing data or fetching information. Using both of these helps manage expectations and prevent those frustrating moments where users think your app isn't loading properly. Okay, so let's dive into optimizing those images. It's a really important step for any front-end developer. First off, why do we even bother? Well, huge image files slow down your website, making it frustrating for users and hurting its chances of ranking well in search engines. The good news is there are some simple techniques you can use. Start by thinking about the right format. WebP is amazing if browsers support it, offering better compression than JPEG or PNG. If not, JPEG is great for photos, and PNG works really well for graphics that need transparency. Don't forget to resize images before uploading them. Make sure they're only as big as they need to be. Compression tools like TinyPNG can help reduce file size without sacrificing quality. Finally, consider lazy loading. This means images aren't loaded until the user scrolls down and sees them. It makes a huge difference in initial load time. Okay, so we've talked about the big frameworks, but sometimes they're overkill or don't quite match your project. Let's explore some excellent alternatives. Tailwind CSS is really popular because it gives you all the styling tools you need in small, reusable bits. Think of it like building with Lego blocks for your design. Svelte takes a different approach by compiling your code during build time, which can mean smaller, faster websites. Sanity.js is a newer framework that's great if you want to focus on components and structure. And, of course, Bootstrap 5 is still around and remains a solid choice for quick development. Okay, let's talk about optimizing your React apps with the React Profiler. It's a fantastic tool built right into Chrome DevTools. Basically, it helps you spot where things are slowing down, areas that need some attention to make your app feel snappier and more responsive. It records how each component renders, showing you exactly when they render, how long they take, and which components are responsible for those longer renders. The timeline view is really useful for seeing the big picture, and you can then drill down into specific events to pinpoint the exact lines of code causing a delay. You'll see features like a component tree that shows your app's structure, a render trace detail in each render event, and even a flame chart, a visual way to understand how much time is spent in different parts of your components. Okay, let's talk about expanding your front-end apps with third-party SDK. Think of these as pre-built tools that add a whole lot more functionality beyond what you might be able to build yourself. You've got things like Google Analytics, which helps you understand how users are interacting with your site, where they're clicking, what they're looking at. Then there's mapping services, like Mapbox or the Google Maps API, letting you bring interactive maps into your application. And of course, we can integrate social media platforms, allowing users to easily share content or log in through their existing accounts. It's important to keep security and privacy in mind when working with these tools. Make sure you're following best practices and protecting user data. Also consider the performance impact, as external services can sometimes slow things down. Okay, let's talk about modern CSS layouts. We're moving beyond older methods and embracing Flexbox and CSS Grid. These are game changers for building responsive websites. Flexbox is fantastic when you need to arrange things in a single line, like aligning items side by side or creating navigation menus. It's really easy to pick up. On the other hand, CSS Grid is designed for more complex two-dimensional layouts, letting you create precise grids with rows and columns, perfect for arranging content in distinct areas of your page. Both are incredibly powerful, and often they use asterisk together asterisk to build truly dynamic websites. Let's explore a little bit of the code now. Okay, let's talk about taking your UI to the next level with animations. Animations aren't just fancy, they really help users understand what's happening on screen and make interactions feel more intuitive. We can create simple animations directly in our CSS, using properties like fade-ins or slides. But for truly complex animations, think intricate transitions or synchronized movements. JavaScript libraries like GSAP or Anime.js come in handy. These libraries give you a lot of control and make it easier to manage complicated sequences. Okay, let's dive into keeping your websites fast. First, you need to set some goals for performance. Think about how quickly things load, like when the initial content appears on the screen or when the page is fully interactive. We use metrics like FCP, LCP, TTI, and TBT to measure this, and aim for specific targets based on your app's needs. Now Lighthouse is a fantastic tool that can really help you with this. It's built into Chrome DevTools and automatically checks all sorts of things: performance, accessibility, SEO, giving you a clear picture of how good your website is doing. Thank you for watching.